Welcome back to my channel. My name is Juan, this is Crypto Sheinix, and in this channel I teach you about blockchain technology, DeFi and cryptocurrencies. In this video I'm gonna do a DeFi 101 introduction, and this is a talk that I gave for a company here in New Zealand, so it's gonna be in English. So let's get started. Here we are, DeFi 101, an introduction to decentralized finance. In this session we're gonna see an introduction to decentralized finance. We're gonna see what it is. Well, we're gonna see the DeFi stack, the DeFi primitives, stablecoins, the decentralized exchanges, specifically AMMs. I'm gonna talk what are the oracles. We're gonna see what are money markets, and then we're gonna see a little bit of yield farming and other stuff, just the tip of the iceberg that it is DeFi. Alright, so let's start by defining DeFi. In my view, is an open composable financial infrastructure. What does this mean? Well, it means that it's accessible by anyone, and when we say anyone, it's consumers and developers alike. What it means is that as a consumer you can access 24/7. It is trustless. You don't have to trust in any intermediary. There is no company or person behind these DeFi protocols or applications. So it's all in the blockchain and is handled by smart contracts. So everything is automated. And when we say that it's accessible by developers, it means that also developers can look at the code and can copy the code and can start doing their own modifications to these protocols to create a new product, or even combine different protocols, different DeFi protocols to create a new product, a new value out of there. So that is a little bit of what is accessible by anyone. And then also there are no intermediaries, no KYC at the pure concept of DeFi, at the pure smart contract level, if you will. There is no KYC. There could be layers on top of this where we have a front end where we KYC our users, but in general we say that it's kind of decentralized and we don't need KYC. This is very discussable. We could do like a whole topic about that. And of course, yeah, because it's in the blockchain environment, we can operate with this 24/7, and it is borderless from anywhere in the world, and is highly interoperable. And you will see definitions in DeFi that talk about money Lego, and this is what I meant by developers can grab different applications and combine them together, or send money from one smart contract to the other one and start playing around with all these composable financial infrastructure. And then we go to that definition again. It's just an infrastructure where everyone can access and start playing around and taking some components and modifying them and creating a new product out of it. We already said that it's powered by smart contracts. Smart contracts are by its nature open source, so everyone can see the code, and that gives another feature very interesting, which is transparency. In the current financial market and current financial private infrastructure, we cannot see what's going on with our money, where does it go. You only see what the banks tells you. With blockchain we can always have the traceability of our funds, and this applies to DeFi as well. And it is a space that is continuously evolving by its nature, and this means two important things. From one side of the coin, we have a high innovation and speed. It really, if you really think about it, many developers around the world talking to each other, copying code, creating different stuff. It's amazing the level of innovation that you can have there and the speed on which these products can ship. But the other side of that coin is there is a lot of security risk. There's been billions of dollars stolen from these applications in the past, and it's extremely risky to operate in DeFi. You had to know what you're doing. You had to be a little bit of blockchain savvy to understand what's going on when you connect your wallet and when you approve a transaction and when you start to operate with these decentralized applications. So that is the other side of the coin. There is a lot of security risk, technical risk, economic risk, hackers everywhere. So be aware if you decide to enter to this space. That's gonna be a little bit difficult at the beginning if you don't understand and if you don't educate yourself. Let's go now to the DeFi stack. I want to share this particular image because I think it's important to understand the different layers that we can have in DeFi. And here you can see the first layer that we have in this stack is the units of value. What does it mean this? It means like the units of value that we operate around this ecosystem. We operate with cryptocurrencies like Tether, DAI, USD Coin, WBTC, and many other tokens. These are the cryptocurrencies that we all know, but it's important to understand there are also other types of tokens that don't mean exactly money, like tokens that can represent a receipt for depositing tokens in a smart contract. So how do you know, or how does the smart contract know that your address, for example, deposited a certain amount of DAI in the smart contract? So it has to give you a receipt that it says, hey, if you come back again here to this DeFi protocol with those tokens, well, I'm gonna give you the amount that corresponds to those receipt tokens. I hope you understand this. As a user, you don't have to understand this and you don't see those tokens on your wallet, but I want just to give a little bit more explanation on what's going on this DeFi stack. The second layer is the transaction layer that we all know, and we have like 2 layers, and nowadays we are talking about 3, 4 or end layers really, but you have to understand that we have the layer 1, which is the blockchain itself, like Ethereum, Solana, Cosmos, and then you have layer 2s that optimize for scalability, so for speed and for amount of transactions per second. So that is the transaction layer, and many of these DeFi protocols lives on the layer 2. And then you have another layer which is very important, and it is the oracles. And the oracles, we're gonna see a little bit about what they are in this presentation, but you have to think about them as the door for all the information around the world coming to the blockchain. So they are the gateway between all the information in the world, like Bitcoin prices, the weather data, whatever, to the smart contracts that handles these decentralized finance applications. We're gonna see a little bit more about this, so don't worry. And then we have the DeFi primitives, that this is also one thing that we're gonna see in this presentation. And you have lending protocol. These are the things that you can do in DeFi. We have derivative networks, AMM pools, that you can think about them as many things, but basically a decentralized exchange where you can interchange tokens between each other. We have order book exchanges. There are other type of exchanges really, and we have asset management, and we have many more things, but these are probably the basic building blocks of DeFi. And then you have on top of that a layer of aggregators, which basically sit on top of these primitives and start to combine these primitives between each other to create more value out of it, and provide an interface, and you can go many layers on top of that and try to combine and create infinite ways of providing value. And then at the very top of the DeFi stack, we have the wallets and the front ends that we all know, and probably as a user you will be interacting with those directly. This is another way of looking at this. Settlement layer is the settlement layer that we saw, like the layer 1 or layer 2, and then we have the asset layer where all our units of value are there, like the tokens, ERC20 tokens, the NFTs. On top you have the protocol layer, which are these primitives, And then on top of that, you have the application and the aggregation layers. Just another nice way to see it. So let's move on now to one of the most important primitives, which are the stablecoins. The stablecoins are basically cryptocurrencies that follow the price 101 of a fiat asset. We have DAI, LUSD, USDC, USDT, Euro C. They usually follow the ERC20 standard to be interoperable with other cryptos, and they could be classified as fiat backed, so there are more centralized stablecoins where a company guarantees that there is $1 or €1 in a bank account for every circulating token in the blockchain, so they can be redeemed one-to-one to fiat money. And this is something that we need to trust into decentralized entities. Then you have crypto-backed coins that are decentralized. What I mean by decentralized means that there is no central entity that guarantees this money behind, but there is a smart contracts. There are smart contracts that holds a value as collateral for all the money that is floating around in the blockchain. And then we have algorithmic stable coins that can be centralized, decentralized, depending on the algorithm that it's implemented, really. And the current stable coins, they face what is called the Stablecoin Trilemma. So the Stablecoin Trilemma is basically this triangle here that you can see, on which we have on one side capital efficiency, on the other side decentralization, and on the other side price stability or collateralization. And the trilemma says that you can only have two of those sides and you will lack of the third one. So when we think about the different types of stable coins, we can see where each other fit. So in this case, for example, we are talking about the fiat backed stable coins, and we can see the profile here of a fiat backed. So it's low in decentralization because we depend on a central entity, but is really good on price stability because obviously there is always $1 backing up a stablecoin linked to the dollar, and is somewhat good in capital efficiency because you only need $1 in your bank to guarantee a token, one token that represents that dollar. So more or less they are good capital efficient coins. And then we can move to the crypto backed ones, and in this profile we can see that they are high on decentralization, they're somewhat good at price stability, and of course they are not really good at capital efficiency. And this is because, generally speaking, we use a collateral that is crypto backed to mint these decentralized stablecoins. And what that means is that the crypto space, all the tokens are very volatile, so you need a lot of capital to mint a certain amount of stablecoin. So you will need way more money, way more dollar value to mint a stablecoin. You cannot mint one-to-one. So currently in some protocols like Maker, you can, I think it's like 150%. You have to put 150% more of the value that you want to ask, you want to borrow, or you want to mint to account for all the variances in the prices, right? Okay. And then the third one is the algorithmic stablecoins that ideally they are high in decentralization, high in capital efficiency, but so far they haven't been good at maintaining any price stability. So they are really that bad as they say. And we have, of course, the case of USD and many other algorithmic stable coins that they just fall short to provide this price stability, really, although they are kind of decentralized and kind of good at capital efficiency. This really depends on the algorithm that they implement. So now let's move on to the decentralized exchanges, or AMMs. I'm gonna talk about the two types of decentralized exchange that we can find in DeFi. We can find an order book which is very similar to the classic order book of any exchange. And then we have this new innovation, which is the automated market maker. So I'm gonna do a very quick demo or explanation of what the AMM looks like. Very basic, but we usually have two roles in this AMM interaction. We have the trader and we have the liquidity provider. So in this example, a liquidity provider, what it does is just provides liquidity to a pool of coins. And to simplify, we're gonna do a pool of only two coins distributed 50%. A liquidity provider can, for example, add liquidity to the ETH DAI pool, to two cryptocurrencies. And why he or she will do that? Well, in return, the user gets a percentage of the pool fees on the ETH DAI swaps. So basically, every trade that is made on the pool that the user provided liquidity, the user will get some fees, and the fees will be, of course, distributed along all the liquidity providers. So you get like some shares on the pool, and money is distributed based on the amount of shares that you have on that pool. And then on the other side, we have the trader. And for example, the trader, let's say he wants to swap ETH for DAI. The liquidity needed for the trade comes from the ETH DAI pool, and the trader will pay a fee that will get distributed along the pool's liquidity provider. That's what we said before. The price of an asset, and this is a very important thing, is given by the amount of coins we want to swap and the available amount on that pool. So basically based on the amount of money that we want to swap and the depth of the pool. So the amount of money, the amount of liquidity that there is sit on that pool for all the trades. And the innovation around this is what is called a constant product market maker formula. And you will see this formula around, and the most basic formula describes a price curve that is x times y equals k, being k a constant and x the amount of tokens that are in the pool, and y the other amount of tokens that are in this pool 50-50 distribute. So here is an example of the documentation of Uniswap V2, that is the AMM that introduced this concept, the first AMM and the most forked project in DeFi. This is saying exactly the same that we saw on the previous slide, but I want to talk a little bit more about the constant product market maker formula, because it is what it makes this amazing protocol works really well and basically can provide liquidity for any trade. And as we saw, we have a trader and that wants to execute a swap, right? So he wants to exchange tokens A for tokens B. And then we have the pool here. And the important thing to understand is that each trade changes the balance of the reserves, resulting in a new price. When we see here, what we are saying is the price curve defined by x times y equals k, being k a constant. So this is the curve that describes this formula. And on the y-axis, we have the amounts of token B's in the pool, and the x-axis, we have the amount of tokens A in the pool. So what happens is that, let's say the pool starts a certain price. We have 1,200 of token A and we have 400 of token B. If we divide these amounts, we have a price of 3. Perfect. So let's say in the curve, we are here in this dot. So the trader comes and wants to swap 3 tokens A plus a fee, right, that it will go to the liquidity providers, and wants to get, of course, because the price is 3, it will get 1 token B. And then what happens is, okay, we have to input 3 tokens, right? We have to put 3 tokens. When we buy, we just input 3 tokens. So then we will have to move to the right on the x-axis on the amount of token A, because we are putting more tokens A, And of course we will have to go down on the y-axis, so we're going to lower the amount of token B because we are subtracting a token B. And then you can see that the way that we move in this pool is defined by the curve. So we move through here to this point here, and this is where the pool ends after this trade. It ends with 1,203.03 tokens A and 399 tokens B, because we get the token B. And then the price, if you divide again, the price now increases, and this is the next price for this pool. And again, trades change the balance of reserves, resulting in a new price, and this is the constant product market maker formula. If you understand this, you understand 80-85% of what it is an AMM. Then there is complexities on top of this, but this is basically the main idea of these automated market makers. There is no other person or trade behind. You just trade against a pool of tokens. Okay, let's move on now to oracles. What are oracles? They're basically are the actors that connect the blockchain's smart contracts with the external systems. The external systems can be any data that can be consumed by the smart contracts. What I mean is, it could be the weather data, it could be the forex exchange data, it could be a result match on a football game, it could be whatever we want. It's just external data in the world, in the internet basically, but it has to come somehow to these smart contracts for them to start deciding on this data and automating any financial process. So oracles are a fundamental piece of DeFi, as they expose lots of information about prices, liquidity, etc. needed for the smart contract to work. And I'm gonna talk about now the oracle problem. So the oracle problem, we can describe it with this example. Let's say we have a smart contract that makes some bets on Bitcoin price, and we have two actors here, Janine and Alan. And Janine bets that Bitcoin will be about 40k by August 2023, and Alan bets that Bitcoin will be below 40k by August 2023. So they made their bets in this smart contract, they put money in this smart contract, and the smart contract on August 2023 will somehow get the price of Bitcoin through an oracle, and then based on that price decide who is gonna send the money, who's gonna get the money of the bet. So now the August came and the oracle provides the Bitcoin USD price at 40,300. This means that Sheinix wins the bet, but there is a problem here, and the problem is that the oracle, it is centralized. So the smart contract depends on a corruptible third party to decide who wins the bet, and it is a single point of failure, because nothing guarantees that Sheinix could have gone on the side and attacked the oracle, or maybe did something with the company and say, hey, let's share, you know, the winnings of this bet if you provide this price on this day, right? There's prone to corruption, really. So the idea behind is that we don't use a centralized oracle provider, because we are basically on the same place as we are in Web 2 and depending on banks and centralized entities again. So the result, or what we have now, it's decentralized oracle networks, where the network itself can fetch from different sources, and the network itself can validate that the source of truth makes sense, and also can penalize to participants that they don't provide the correct information. And then after that, in a lot of other processes more complex than that, can provide a more reasonable, secure information for a smart contract. Still nowadays, it's one of the points of failure in DeFi, where still there is a lot of hacks based on oracles. So You have to be aware of this. Biggest provider of Oracle in DeFi so far, as far as I know, it is Chainlink. And that is all about you have to know as an introduction to oracles. Let's move to another DeFi primitives, which is the money markets. And basically what they do is they provide liquidity by allowing users and protocols to borrow, lend, and one other thing that not many people talk about, but liquidate position. So liquidate a position that is borrowing some money and is about to be liquidated, so a third party can come to these protocols and pay out that debt and get the collateral, right? So I'm gonna explain later what is this about the collateral and the borrow. We don't have any intermediaries, really. It's again no company behind. It's all handled by smart contracts, and the interesting thing is that there's no loan terms like repayment schedule or maturity, etc., and everything is handled automatically by smart contracts, incentivizing the actors through different mechanics. So it could be like raising and lowering interest rates on the debts and on the collaterals. It could be a liquidity mining incentives. It could be a lot of things really, and they usually change over time. But the idea is that you don't talk to anyone. No one is claiming anything on you when you take these loans, but you will be incentivized, financially incentivized, to repay or actually to borrow. So this is how it works on an example. You have the liquidity pool again, where there's some money there, and you have a lender and a borrower that could be the same person. But let's say we are on the role of the lender. So a lender can deposit liquidity on the pool in exchange for an interest rate. So the smart contract, the DeFi protocol, pays you an interest for putting some money there, right? Okay. Then the borrower, which in generally is kind of the same, because you have to provide, you can be a lender without a borrower, of course, but generally speaking, what most people do is they deposit a collateral as a lender and they borrow against that collateral. So the borrower deposits liquidity on pool in exchange for interest, right? Percentage as the lender, and also the possibility of use the liquidity as loan collateral. So the borrower pays interest on the debt, of course, so you borrow some money and you pay interest. What happens here is that the collateral you put on, it has a value. And if the value falls below a certain threshold that cannot cover the amount of money that you borrow, then you will be liquidated. And this is what the liquidators do. This is the other actor. Liquidators, bots are, generally they are bots, are looking for under collateralized positions ready to be liquidated for a profit. So there's like bots, and yeah, generally they're bots. They're not even people, but they're bots. They're looking at the positions and checking, and if any position is about to be liquidated, they can come, and it is like a market. They can come and say, hey, I'm gonna pay this debt and I'm gonna get this collateral, and the protocol itself also incentivize this, because this makes the protocol very, very efficient. So yes, you have to put more money than you can borrow, but this is how it works in a decentralized world. Okay, and then we just get to yield farming and more. We are not going to explain much more in this introduction, because DeFi is a universe. It's not even like a world, it's a universe of things. But if you hear about yield farming, it means like earning rewards, combining the different DeFi applications and taking your money from one protocol to the other one, and whenever there is incentives for liquidity, you go there and you do that, and then you move and you move and you move. And this was very prominent thing to do during the DeFi summer in 2020. Nowadays there's still some yield farming going on. There's a lot of platforms that can automate this, but generally speaking, it's a funny term in the industry that I quite like. And of course, you can have infinite strategies to combine and take advantage of the incentives that these protocols gives. So just for you to be aware, there is many other DeFi building blocks. We have like synthetic assets, we have liquid staking, there's prediction markets, indexes, insurance, derivatives, options, futures, perpetual contracts. There's even NFTs in DeFi, like you can put your NFT as collateral and borrow against that. There is a whole train around real world assets. There's LBPs. There's protocols to do dollar cost average, automated, and there's many more things, and this keeps evolving every week basically. So that is an introduction to DeFi. I don't think we're gonna get to the flash loans in this particular video, but just write in the comments if you want to see a demo of flash loans. I hope you learn a little bit more about DeFi. This is a very basic and introductory talk. I'm gonna start putting some more content in English as well, because I'm giving some talks in English and I'll just share them here for you. Please like, and if you're not subscribed, subscribe, and we'll see you in the next time.